Hello again, my students. I continue in this video the analysis on the charging of the capacitor. In the last video, I studied the cases at t equal to 0, in which the charge is 0 and the voltage across the capacitor is 0, while the current starts from a maximum value. And also at t equal 1 tau, we obtained that the charge reaches 63% of the total value, while the current reaches 37%, means the current drops by 63%. Clear? Let me emphasize on it here. At t equal 1 tau, t equals 1 tau, 1 period, Q reaches 63% of its maximum value or total value of its maximum value, while the current I drops, let me emphasize on it, drops by 63%. Clear? Drops by 63% because the remaining value is 37%. Clear? Okay. Let me study now the case when t equal 5 tau. This case, okay? At t equal 5 tau. So at t equal 5 tau, let's find the charge. Q equal Q, that's the main function of the charge. 1 minus exponential minus 5 tau over tau, you get minus 5, right? So if you do the calculation, approximately 0.993 Q. Reality equal 99.3% of the total charge. Means practically the capacitor is completely charged, right? And let's find the current. Or you can say here also this is applicable, or U across the capacitor 99% of E, or approximately E. The voltage across the capacitor is equal to the voltage across the battery. And let's find the current. I equal E over R, the function of the current. Exponential minus T over tau means minus 5, which is approximately 0. So the current drops 0. Here, the capacitor practically completely. Here you can say C practically fully charged or completely charged at equal 5%. Okay? Any problem? Now, after studying these particular cases, which are very important, let's find now the graphs of of Q, say, first Q. I said Q or U the same because they are proportional. Similarly, I or UR means the voltage across the resistor also the same because they are proportional, right? So you can say UQ and I, and as I said, or here, or UC, which is proportional to Q, and and UR, because this is a voltage across the resistor, because UR is proportional to I. Clear? So the same. Let's draw the graph here. This is the time, and this is Q. Okay? I'm going to take this scale, tau, 1 tau, 2 tau, 3 tau, 4 tau, 5 tau, etc. And I want you to express or take the scale on the y-axis in terms of percentage. Say this is, for example, the maximum charge Q. This is here 50% of Q, means this is what? Q over 2. So here we have 25% and here we have 75%. That's the graph of Q. Now let's locate our point. At t equal to 0, the charge is 0. So here is the first point. At t equal to tau, the charge is reached how much? 63%. Here is 50% and here is, 100%. 100. And this is 50%. So this is 75%. And this is 63 exactly. So the curve passes through this point. Clear? At t equal to 5 tau, it reaches almost 100% of Q. In fact, it's 99%. So this acts as a horizontal asymptote. Let me erase this point and put it here. Okay, here it is in reality. Now draw the graph. So the curve passes like this. Increases, pass through this point, and then go asymptotically. In fact, like this, okay? It's like this. Clear? That's the graph of Q as a function of time. Let me now draw the graph of I as a function of time the same way. This is the time and this is the current I. But don't forget, you can say this is also UC, voltage across the capacitor, because it is proportional to Q, right? And this is also, you can say UR, as I said before, because it is proportional to I. So the same, do the same scale. 1 tau, 2 tau, 3 tau, 4 tau, 5 tau, etc. Here is the initial current. Okay, put it in black. This is I0 or E over R. And this is half of it. I0 over 2. Okay, here 25%, and this is what? 75%. 0. This is also 0. Now at equal to tau, the current drops by 63%. Means the remaining part is 37%. Located, where's 37%? Here's 50, here's 25, so this is 37, right? And this is tau. So the curve passes through this point. But before, at equal to 0, it is I0, the current drops from maximum. And equal 5 tau, this is 5, sorry, not here. 5 tau is here. It passed through this point, means reach 0 value, 0. So if you draw the curve, the current decreases or falls exponentially like this. Clear? This is the growth of voltage. This is decay of current. Clear? I have an important question for you. Important question. I want you to show that, and this is always the case, show that the, sorry, that the tangent tangent to the curve of Q or I, doesn't matter, or I cuts the horizontal asymptote at a point t equal tau. Okay, t equal tau. Let me write tau in this form, capital T. Okay, let's show this. Means here it is. If I draw the tangent to the curve, cuts this curve at equal tau. Let me change the color of this line. I will use this color. Okay, clear? Good. Similarly, here is a tangent. Okay, now does really cuts? Yes, it has to pass through this point. Notes here. Here T equal tau. So this is the horizontal asymptote. This is the tangent. They intersect at equal to tau. Can you verify this in mathematics? You should do this. Okay? It must be a very easy job for you. Similarly, let me take the tangent here. This tangent cuts the horizontal asymptote at equal tau. Clear? The same here. At equal tau. And also it must be easy job. You have to recognize